Hey guys, good evening. Good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats. Let me know quickly in the chats if all of you can hear me, if I am perfectly audible, visible to everyone, quickly. Everyone means everyone. Say yes or no in the chats quickly. Say yes or no in the chats quickly. Everyone, people. All right, all right, all right. All right, guys. So as you all must be knowing, well, it is a new session basically, right? It's a new session where we will be doing the PYQs, chapter-wise PYQs of your chemistry. A lot of students must be thinking, what about the series which was currently going on? The series will go as such. The series which is happening on this particular channel right now, I mean, wherein we are completing a chapter in 3 to 4 hours, right? It's going to go as such. But in between, I'll keep on coming up with these sort of sessions as well, right? Otherwise, it's very boring. Yeah? And these sessions, these sort of sessions wherein discussing PYQs, chapter-wise, etc., etc., these are also very, very, very beneficial when it comes to your NEET 2026 preparation. Okay? So, my dear students, I have marked the heading as all PYQs of chemistry in one shot, right? But you know, it is not possible to cover all the PYQs in just one session. So I will be taking almost like 3 to 4 sessions to cover all the PYQs of chemistry. And today is session number 1, which will be of the duration 2 to 3 hours. Okay? Right? But I would want you guys to be with me till the end for sure. I would want you guys to be with me till the end. The session duration is going to be 2 to 3 hours, right? I'll be discussing chapter-wise PYQs of your chemistry, which have been asked in the NEET examination in last 10 to 15 years, right? And at the same time, as I told you, I'll be taking some 3 to 4 sessions to cover all the PYQs of your complete chemistry. All right? So I hope you guys are ready with your pen and paper, because you are going to solve the questions with me. You are going to solve the questions with me. Okay? All right, I want you guys to call up all your friends because this session is going to be very, very, very beneficial. Why is that? Because every year when you see the NEET paper, particularly in the subject chemistry, almost like there will be 10 to 15 questions directly or indirectly every year coming from the PYQs. Okay, 10 to 15 questions, guys. So to cater those 10 to 15 questions, it is highly, highly, highly beneficial for all the students. Okay. All right. Perfect. Yes, you are going to get the PDF of this session as well. You will be getting the PDF of this session as well on my Telegram channel. The name of the Telegram channel is Wassim Chemistry Official. WASSIMBHAT Chemistry Official. That is the name of the Telegram channel on which I shall be sharing the handwritten PDF of this particular session. So again, let me repeat the same thing. In order to cover all the PYQs of your NEET, when it comes to the subject chemistry, I would require some 3 to 4 sessions. And today it's going to be session number 1. Okay, session number 1. The duration of the session will be 2 to 3 hours, right? So almost like if I'll be conducting some 4 sessions to cover all the PYQs, that means 4 3s are 12. Almost like in 12 hours, we'll be covering all the PYQs here. Okay, that too in detailed format. That too in detailed format. I hope you guys are ready with your pen and paper. Are you? Let me know once in the chat so that we'll start. Sir, what about ionic equilibrium? Ionic equilibrium will be also done. Don't worry. I told you the current series which is happening on this channel, that will go as such. Don't worry. It won't stop. Don't worry. Don't worry. And guys, at the same time, I'll tell you just one thing. Just give me a second. I'll tell you one thing. When you open this particular channel, you have got everything available here on this channel. Everything means everything. Everything means everything. You name a single chapter, that will be available on this channel in the detailed format. Talk about any chapter. In detailed format, everything is present on this particular channel. You just have to search here the chapter name. That's it. Chapter name, and with that, write Unacademy NEET English. Every single thing is here on this particular channel. Does not matter if you are saying, for example, the last year session. The content is the same, right? Content is the same. You can consider those lectures as well, right? See, if you go to the playlist, let me show you first of all certain things and then we'll start. If you open the playlist, there are a lot of playlists, guys. There are a lot of playlists. For example, if you open this particular playlist, you can see mole concept, GOC, chemical bonding, solution, redox, thermodynamics, structure of atom, top 100 questions of mole concept, top 100 questions of chemical bonding, electrochemistry, part 1, part 2, thermochemistry, top 100 questions of thermodynamics, chemical equilibrium, ionic equilibrium, basics of organic chemistry, chemical kinetics, electrostatics, periodic classification, capacity, like every single thing is here. Every single thing is here, right? You can consult any lecture. We have kept complete playlist for you guys, right? There won't be a single chapter that will be missing here. Yes, there will be one chapter, I think salt analysis I'm not taught yet on this particular channel. That I'll be teaching soon. Okay? Perfect. So everything is here on this particular channel. You just need to open the playlists, different playlists, or just search the chapter name, whatever chapter you want to search, right? Search here. And for example, you want to search electrochemistry. Search electrochemistry and after that write NEET English, Unacademy NEET English. You'll be getting the lectures, right? Perfect. So should we start, guys? Should we start? Is everyone ready? Should we start? One more important thing which I want to discuss with you. One more important thing, and after that I'll be starting. Just give me a second. One more important thing, guys, which I want to discuss with all of you. Just a second. There was one video which I had posted few days back. This chemistry guest paper, right? This chemistry guest paper. This was the video which I had posted few days back. So basically in this particular video, I had given you the chapter-wise most important topics from which questions are asked every year, right? For example, in mole concept, there are 3 to 4 topics which are asked every year, almost. Similarly, in all the other chapters. What I'm planning to do is I'll be doing a marathon of these topics as well. These are almost like 50 topics. I'll be covering these 50 topics in like few. I'll conduct some 3 to 4 sessions for these topics as well, and we'll be covering these 50 topics separately also. Okay? You just remain updated, right? Keep on following this particular channel. Every single thing will be happening here. Because a lot of students were asking me, sir, do a marathon of these 50 topics which you have given here, from which 90% questions are asked every year in the NEET examination. So what I've thought, let's conduct a marathon of these topics as well. Okay? Because I could see there were a lot of comments on this particular video where students had asked to take the marathon of these particular topics. For example, here, sir, can you start a new series completing all these important topics, right? There are many comments like that wherein I felt like I should take a marathon of these 50 topics of chemistry, like which will cover 90% of your NEET paper basically. Okay? So we'll start it with chemistry, then other subjects will also follow this. Okay? Then other subjects will also follow this. KK sir will be doing amines in few days, in 2 to 3 days. Okay, chalo, let's get going then. Let's get started. So tell me first of all, I will be starting as per the NCERT sequence only. So we'll be starting with the PYQs of mole concept first. How many of you are done with the mole concept? Say yes or no in the chats quick. Everyone. How many of you are done with the mole concept? Honestly, you can say yes or no. I mean, the ones who have watched the lecture of mole concept from any of the playlist on this particular channel, or if you have studied from some other place also, does not matter. Just tell me, how many of you are done with the mole concept? If you are done with the mole concept, then you should be in a position to solve each and every question, guys. If not each and every question, at least 70% of the questions which I'm going to show you today, you should be able to solve them on your own. You should be in a position to solve them on your own. Okay, so let's get going then. Let's get started. I hope you guys are ready with your pen and paper. The question which I'll be giving on the screen. So try it out first and keep on writing the answers in the chats. Okay, keep on writing the answers in the chats. Well, I've added some JEE mains questions also in this particular session. Not only the NEET questions, not only the NEET PYQs. The JEE mains questions also are some of the questions I have kept in this particular session. Even let me tell you, you can make a separate notebook for this particular PYQs. You can make a separate notebook for this as well. That will be also beneficial for you when it comes to the revision purpose. Again, time duration of this particular session will be 2.5 or 3 hours. I'll be taking 3 to 4 sessions to cover all the PYQs, and today is session number 1. So let's start without wasting a lot of time. So my dear students, the first question which was asked in your NEET 2020, I believe you would have solved this question at least once. Look at the question carefully. Which of the following has maximum number of atoms? Which of the following has maximum number of atoms? What do you think about this? What do you think about this? Which of the following has maximum number of atoms? So my dear students, how do we deal with such kind of the question? Pretty much simple. Have a look. 1 gram of magnesium. 1 gram of magnesium. So first of all, convert the given quantity into moles. So how many moles of magnesium we have in the first option? Given mass of magnesium divided by molar mass of magnesium. These are the moles. Now the second step is moles are to be multiplied with Avogadro's number. So when you multiply this with Avogadro's number, you get the value Na divided by 24. Since magnesium is an atomic form, right? So this is basically the number of atoms. The number of atoms of magnesium. In the first option, we have got Na by 24 atoms of magnesium. Number 1. Number 2, 1 gram of O2. Oxygen here is in molecular form. So first of all, convert the given quantity into moles. So number of moles of O2 will be equal to given mass divided by molar mass, right? These are the moles. Now moles are to be multiplied with Avogadro's number. So it becomes Na by 32, right? Since oxygen here is in molecular form, so these are molecules. These are not atoms. These are molecules, right? Now you know, one molecule of O2 contains 2 atoms. If one molecule O2 contains 2 atoms, therefore, these many molecules of O2 will contain how many atoms? So multiply this term with 2, it becomes 2, 1, 2, 16. So Na divided by 16 atoms in total. So here we have got Na by 16 atoms. Look at the third option, 1 gram of lithium, right? Convert the given quantity to moles. So number of moles of lithium is equal to given mass of lithium divided by molar mass of lithium. So these are the moles. Now moles are to be multiplied with Avogadro's number. So it becomes Na by 7. So since this is the atomic form basically, so these are basically your atoms. These are basically your atoms. Similarly, given mass, number of moles of silver. Given mass divided by molar mass, right? Then multiply this with Avogadro's number. It becomes Na divided by 108. These are the atoms. So we have to check which of the following has got the maximum number of atoms. Tell me. Maximum number of atoms. Na by 24, Na by 16, Na by 7, Na by 108. So I would go with option C. That's the correct answer of this particular question. Right? Simple. Perfect. Question number 1. Moving on to the question number 2. The question that has been asked in your NEET 2015. What do you think about this one? Every one of you. What do you think about this particular question? Every one of you. We have got a gaseous mixture that contains H2 and O2. We have got a gaseous mixture that contains H2 and O2. For example, this is a container. In this container, we have got H2 and O2. In the ratio of 1:4 weight by weight. So basically, the mass ratio of these gases in the container is given to us as 1:4. The mass ratio is equal to 1:4. What do we have to calculate? We just have to calculate the molar ratio. We just have to calculate the molar ratio. Correct? Mass ratio is given. Molar ratio is to be calculated. Molar ratio is to be calculated. First of all, mass ratio is given as 1:4. It means that mass of H2 divided by mass of O2, this value is given to me as 1/4. We have to calculate the molar ratio. Number of moles of H2 divided by number of moles of O2 is to be calculated. Now tell me one thing. Number of moles of H2 means mass of H2 divided by molar mass of H2. Similarly, number of moles of O2 means mass of O2 divided by molar mass of O2. That goes upwards. This particular term as per the question is given to me. How much? It is given to me as 1/4. Now molar mass of O2 is 32. Molar mass of hydrogen is 2. So it becomes 2, 1, 2, 16, 4, 1, 4, 4. The answer is going to be 4:1. So the molar ratio of these gases here is nothing but 4:1. This is the correct answer of this particular question. So I'll go with option number 1. Right? Perfect. Is it clear? Is it clear? Guys, remember the approach of each question. Remember the approach of each question, okay? Moving on to the next question. Before solving the next question, okay, look at this. The question has been asked in the year 2015. The question has been asked in the year 2015. You should be again in a position to solve this. The number of water molecules is maximum in. Where are the water molecules maximum? Tell me in the chats quickly. I want the chats to be running. If anyone faces any sort of doubt in understanding, just drag the video a little back. It will be a replay for you. Don't ask me to repeat, okay? Just drag the video a little back. It will be automatically repeat for you. People are going with option number D, right? We have to check where are the molecules maximum. In the first option, you are already given with the molecules. How many? 18. In the second option, we are given with mass. We are given with mass of water. So convert the mass into moles. Number of moles of water will be equal. Given mass of water in grams divided by molar mass of water. The value is 0.1. These are the moles. Now moles are to be multiplied with Avogadro's number. You will be getting the molecules. So in the second option, we have got 0.1 Na molecules. Here we are given with 18 grams of water. 18 grams. So tell me how many moles of water these are? Given mass of water divided by molar mass of water. So we have got 1 mole of water. Now moles are to be multiplied with Avogadro's number. So we'll be directly getting Na molecules here. So in this option, we have got Na molecules. Look at the next one. 18 moles of water. Already we are given with moles. So moles are to be multiplied with what? Avogadro's number. You will be getting the molecules. So where are the water molecules maximum? In the first option, 18. Second option, 0.1 Na. Third option, Na. Fourth option, 18 Na. So option 4 has to be the correct one among all. Right? Moving on to the next question. This question was asked in the year 2014. Quickly, people. Everyone in the chats. Everyone in the chats. Quickly. Don't use chat GPT, okay? Don't use chat GPT. Guys, I want the chats to be running. I want the chats to be running. People are coming with option C. Is that? See, 22.4 liters of H2 is mixed with 11.2 liters of Cl2 each at STP. Moles of HCl formed is pretty simple question. As per the question, your H2 gas is reacting with Cl2 gas. And you should know when H2 reacts with Cl2, it forms HCl gas. Tell me first of all, is the reaction balanced? No. So now the reaction is balanced. So initially at time t is equal to 0, how many moles of H2 are we given with? We are given with 22.4 liters of H2. So technically we are given with 1 mole of H2. 11.2 liters of Cl2. That means 0.5 moles of Cl2. Right? Given volume divided by 22.4. Given volume divided by 22.4. Correct? Now if I ask you which one is the limiting region among the two? Limiting region. 1 divided by 1 is 1. 0.5 divided by 1 is 0.5. Which one is getting lesser value? This one. So this is the limiting region. So this is going to decide how much HCl will get formed. This limiting region is going to decide the formation of HCl. Now, as per stoichiometry, 1 mole of Cl2 gives 2 moles of HCl. If 1 mole gives 2 moles, 0.5 moles will give 2 into 0.5, which comes out to be 1. So I would say 1 mole of HCl would get formed at the end of the reaction. 1 mole of HCl would get formed at the end of the reaction, right? Simple. Perfect. Moving on to the next question. The question has been asked in the year 2010. What do you think? What do you think about this one? The number of atoms in 0.1 mole of triatomic gas. So basically, you've got a triatomic gas. Let the gas be like this, A3. How many moles of this gas are we given with? We are given with 0.1 mole of this. Now, when moles are to be multiplied with Avogadro's number, what do I get? I'll be getting molecules. So these are the molecules of A3. What do I have to calculate? I have to calculate atoms. So basically, 0.1 mole A3 means we have got these many molecules of A3. Now, you already know 1 molecule of A3 contains what? Contains 3 atoms. Now tell me, if 1 molecule of A3 contains 3 atoms, how many molecules of A3 we have? 0.1 Na. So 0.1 Na molecules of A3 will contain 3 into 0.1, which comes out to be 0.3 Na atoms. So these are the total number of atoms which are present in 0.1 moles of A3. As simple as that. First, convert the given quantity to moles. It's already given as moles. Moles are to be multiplied with Avogadro's number. You get the molecules, right? So 1 molecule of A3 contains 3 atoms. These many molecules will contain these many atoms. So the answer is 0.3 Na. You can put the value of Avogadro's number here, 6.02 to 10 raised power 23, and accordingly you will find the options. People are coming up with option number 2. Yes, it's option number 2. Correct? Moving on to the next one. The question has been asked in the year 1990, 5 years before I was born, right? And this question, as far as I remember, it was asked in your JEE mains as well, 5 years back. What do you think? As far as this particular question is concerned, boron has got 2 isotopes. One is your B10, one is your B11, right? The percentage abundances of these isotopes is given. This is 19% and this is 81%. Right? What do we have to calculate? We have to calculate average atomic mass of boron. Correct? Average atomic mass of boron. Now, my dear students, how do we calculate average atomic mass of boron? The formula is M1A plus M2B divided by 100. Right? This is basically the value of M1. This is what you call as the M2. This is what you call as A. This is called as B. Put the values into this expression. You get the final result as 10.81 AMU. So this is the average atomic mass of boron, which you were supposed to calculate. Simple. Just formula-based question. Yeah? Just formula-based question. Nothing more, nothing less. Moving on to the next question. The question was asked in your JEE mains 2020. Proper NEET standard question. What do you think? What do you think, people? If you look at this particular question, well, you should be in a position to solve this on your own. Sir, bio also will take care of, don't worry. Let's start with chemistry. Bio will also happen. Physics will also happen, don't worry. These sort of sessions will keep on coming on this channel now. Quick, guys, everyone. See, guys, if you talk about chlorine, chlorine has got 2 isotopes. One is Cl35, one is Cl37. Correct? You know, the average atomic mass of chlorine is equal to 35.5. 35.5. This is the average atomic mass of chlorine. Right? Let the percentage abundance of the first isotope is X%. That means this will be 100 minus X. If you would have studied the mole concept properly. Right? This is the value of M1. This is the value of M2. This is the value of your A. This is the value of your B. Now use the formula. M average is nothing but M1A plus M2B divided by 100. This value is equal to 35.5. Now M1 is how much? M1 is 35. A is X. M2 is 37. B is 100 minus X. Divided by A plus B is 100. And this value is equal to 35.5. When you solve it, when you cross multiple, X value will come out to be 75%. X value will come out to be 75%. If this is 75, this will be 100 minus X, this will be 25%. Take the ratio. Take the ratio. This is 1:3. So the ratio is 3:1. Simple. Simple. Did you understand how do we deal with such kind of the questions? I would tell you, you should be remembering this question because I have solved this question 100 times in the sessions. You should be remembering this question, guys. Okay? You should be remembering this question on your own. Chalo. Tell me the answer of this question. The question has been asked 2 times. JEE 2014 and 1979. My God. Wait, give it a try. The ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1:4. So basically, we have got a gaseous mixture. This gaseous mixture contains 2 gases. What all gases? It contains O2 gas as well as N2 gas. Right? These are the 2 gases present here. Well, the mass ratio is given. Mass ratio is given. Mass ratio is how much? 1:4. What do we have to calculate? We have to calculate the ratio of the molecules. We have to calculate the ratio of the molecules. Right? We have to calculate the ratio of the molecules. Let me tell you, ratio of the molecule is same as that of ratio of moles. Whatever is going to be the molar ratio, same is going to be the molecular ratio. Whatever will be the molar ratio, same is going to be the molecular ratio. Okay, now have a look. Mass ratio is 1:4. That means mass of O2 divided by mass of N2, that's given to me as 1:4. I'll be just calculating the molar ratio of these 2 gases. So number of moles of O2 means mass of O2 divided by molar mass of O2. Number of moles of N2 means mass of N2 divided by molar mass of N2. Now this particular value is given to me as per the question, 1/4. Molar mass of N2 is 28. Molar mass of O2 is 32. So 4:1:4:7. So the answer is 7:32. So the molar ratio is 7:32. That means molecular ratio will be also 7:32. So remember, whatever is going to be the molar ratio, same is going to be the molecular ratio. Right? And under identical conditions, same is going to be the volume ratio as well. So anything can be asked related to this. Lot of questions will do mistake here. Lot of questions. The question has been asked in the year 2000. See, when this sort of a question comes in your exam, you feel like, see, this is the easiest question first of all. When you see the same question in the examination hall, you feel like they cannot ask such an easy question, right? And slowly, you start using your brain, right? You start using your brain. Yeah, and eventually you mess up. Ikra, you can go to some other channel, okay? This channel is not meant for you. You can go to some dancing channel or somewhere, okay? Not here. People have come to study here. It's better you get the hell out of my class. All right, what do you think about this one? Quick. I'm telling you, a lot of students mess up in this sort of a question in the examination hall. Because they feel like that this sort of easy question cannot be asked. So they keep on relating this concept with some other concepts and all, and they are done. What do we have to calculate? Total number of electrons in one molecule of carbon dioxide. Carbon dioxide, CO2. This is your CO2, right? This is your CO2. Carbon, atomic number 6, mass number 12. 8, 16. 8, 16. In one atom of carbon, there are 6 electrons. This oxygen carries 8 electrons. This oxygen carries 8 electrons. So in one molecule, in total, there are 22 electrons. So direct answer is 22, right? So don't use your brain a lot in this. Perfect. This sort of a question, this question was asked in the year 2000. Can you give this a try? Can you give this a try? Can you give this a try? Quick, everyone. Can you give this a try? Wassim Sir. Kashir Shuri Gasan, Kashir channel pet. Unacademy J&K pet. Issue English channel. Issue South Indian student khadr mainly. Agar Angrezi samujhi ma Telugu Kashir channel pet gasun. Then is Kashir pet parnama. ठीक है जिगर Guys, again, this sort of a question you should be in a position to solve. I've solved this question many a times in the live sessions. Majority is coming up with option C, and option C is the correct answer, let me tell you. Option C is the correct answer. See how? First of all, imagine this is your container, and in this container you have got H2 gas, you have got O2 gas, and there is CH4 gas, right? As far as the question is concerned, equal masses of all the gases are kept in the container. So basically, mass of every gas in the container is same. Let the mass of H2 be x grams, this will be also x grams, this will be also x grams, right? This will be also x grams. So, mass of H2 in the container is x. So, mass of H2 divided by molar mass of H2. Mass of O2 divided by molar mass of O2. Mass of CH4 divided by molar mass of CH4. These are your moles. These are your moles. X by 2. These are the moles of H2 in the container. Moles of O2 in the container. Moles of CH4 in the container. So, if I take the ratio of these moles, if you look carefully, it's going to be 1 by 2 is to 1 by 32 is to 1 by 16. This is the ratio of the moles, right? Now, let's convert this into the simplest form. Look at the denominators. If you take the LCM of the denominators, LCM of 2, 32 and 16 will come out to be 32. So, if I multiply this with 32, this with 32, as well as this with 32, right? So, it's going to be 16 is to 1 is to 2. So, this is the ratio of the moles. And whatever is going to be the ratio of the moles, same is going to be the ratio of the volumes. Whatever is going to be the ratio of the moles, same is going to be the ratio of the volumes. Remember that directly. Okay? This question was asked in the year 2019. Give it a try, quick. Quickly. Amine session will be on Thursday or Friday. Thursday or Friday, okay? Quick, people, quick, everyone. Good. See, guys, the number of moles of hydrogen required to produce 20 moles of ammonia through Haber's process. Haber's process means N2 reacting with H2 and forming what? And forming NH3. This is your reaction. Now, as far as the question, how many moles of ammonia we are supposed to make? We are supposed to make 20 moles of ammonia, right? And in order to make 20 moles of ammonia, how many moles of H2 are required? So if I use a stoichiometry, I can say 2 moles of ammonia are produced from 3 moles of H2. Stoichiometry is telling me that in order to make 2 moles of ammonia, 3 moles of H2 are required. So that means in order to make 1 mole of ammonia, how many moles of H2 are to be required? 3 by 2 moles of H2 are required. So therefore, in order to make 20 moles of ammonia, how many moles of H2 are required? 3 by 2 into 20. The value comes out to be 30. So 30 moles of H2 are required, right? 30 moles of H2 are required. I believe this is clear. I believe this is clear. Tell me the answer of this question. The question has been asked in AIMS 2019. Just give me a minute. Just give me a minute. You done with this? Sir, where are you from? I'm from Kashmir. Done with this question? What do we have to check? We have to check. Choose the correct option. Okay, we have to check. Where is the B limiting reagent? Where do you think B is the limiting reagent? See, the reaction is A plus B. It gives what? It gives AB. So, we have to check in which of the following options B is the limiting reagent, right? Since the stoichiometric coefficients are 1 and 1. So, where is the amount of B less? Where is the amount of B less as compared to A? It is option number C, where we have got lesser B atoms as that of A. Right? Perfectly done. Okay. The question has been asked in the year 2008. Give it a try. Give this question a try. Everyone. Everyone. As far as this particular question is concerned, we are doing the combustion of propane. Propane is C3H8. You are making it to react with O2. It will form carbon dioxide and will form water. When you balance the reaction, this becomes 3 times, this becomes 4 times, this becomes 5 times, right? Now, as per the question is concerned, we are doing the combustion of 1 liter of propane. If you look at the stoichiometry, in order to do the combustion of 1 liter of propane, 5 liters of O2 are required. That is the question. How many liters of O2 are required to do the combustion of 1 liter of propane? So, in order to do the combustion of 1 liter of propane, 5 liters of O2 are required. That's it. Right? That's it. The question has been asked in the year 1979. Okay, and this was the question asked in your JE as well, JE mains once. Well, this question you can solve only if you know the reaction. If you know the reaction. Now, my dear students, silver carbonate, upon strong heating, when it is heated strongly, it gets converted into silver, and with silver you get carbon dioxide, and with carbon dioxide you get O2 gas as well. First of all, remember this particular reaction. Okay, I want you guys to remember this reaction. Remember this particular reaction. It's important. It is important. Now, people, as far as the question is concerned, what do we have to calculate? As far as the question, we are going to heat up 2.76 grams of silver carbonate. And technically, we have to calculate what mass of silver is formed. That is the question. So, first of all, convert the given quantity into moles. So, how many moles of silver carbonate are we given with? That is going to be given mass of silver carbonate divided by molar mass of silver carbonate. The value will be 0.01. So, technically, we are heating 0.01 moles of silver carbonate. Technically, we are going to heat 0.01 moles of silver carbonate. Now, as per stoichiometry, when 1 mole of silver carbonate is heated, 2 moles of silver are produced. Therefore, when 0.01 moles of silver carbonate will be heated, 2 into 0.01, 0.02 moles of silver will get formed. But do we have to calculate moles of silver? No, we have to calculate mass of silver. Now, how do you convert moles into mass? So, moles multiplied by molar mass of silver. The value comes out to be 2.16 grams. So, this is the mass of silver that is formed, which I was supposed to check, which I was supposed to calculate. I believe this is clear. And people, if this is clear, look at this question also. The question has been asked in the year 2006. Quickly, check it out. Everyone. The question is, how many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? Look at the question. These sort of questions are basically asked in your JEE mains examination, but they can be asked in your NEET as well. So if you look at magnesium phosphate, can I say 4 3s are 12? Can I say 12 moles 12 moles of O are present in 1 mole of magnesium phosphate? I can say something like this, right? I can say something like this. 12 moles of O are present in 1 mole of magnesium phosphate. Therefore, I would say 1 mole of O would be present in 1 by 12 moles of magnesium phosphate. 1 mole of O is present in 1 by 12 moles of magnesium phosphate. Therefore, as per the question, 0.25 moles of O are present in 1 by 12 into 0.25, which will come out to be, this will be 1 by 4, which will be 1 by 48 moles of magnesium phosphate. So I calculated the moles of magnesium phosphate, but I do not have to calculate moles of magnesium phosphate. What do I have to calculate? I have to calculate mass, right? Or moles only. I have to calculate moles only. Okay. So these are the moles of magnesium phosphate. These are the moles of magnesium phosphate that contains 0.25 moles of O, right? Just solve it and see what will be the exact answer. I think it will be this option number 2, 3 point something, right? I think I did a mistake here. Did I do any mistake? How many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? Mg3PO4. Oh, sorry. I have made a mistake here, guys. It is twice. It is twice. So this will be 4 2s are 8, not 12. Sorry, my bad. This will be 8. This will be 8, right? So this will be 1 by 8. This will be 1 by 8. This will be also here 1 by 8. So this will be finally 1 by, this will be 1 by 4. So it will be 1 by 32. Right? 1 by 32. I hope this is clear. I hope this sort of equation is clear. Okay. Look at this question, guys. Look at this question. Look at this question carefully. JEE 2020. The percentage composition of carbon by mole in what? In CH4, in methane. You have to calculate mole percentage of carbon in methane. How do you calculate mole percentage of carbon in methane? How do you calculate mole percentage of carbon in methane? See, if you look in this particular compound, how many carbon atoms do you see here? 1. How many total atoms do you see here? 4 plus 1, 5, multiplied by 100. So it's simply going to be 20%. As simple as that. This is the mole percentage of carbon. This is the mole percentage of carbon in methane. Similarly, if they ask you about the mole percentage of hydrogen in methane, how many hydrogen atoms do you see here? 4. Total atoms, 4 plus 1, 5, multiplied by 100. This will give you the mole percentage of hydrogen in methane. Right? Simple questions these are. Simple questions these are. I believe this is clear. Okay, moving on to the next chapter, that is redox reactions. Moving on to the next chapter, that is redox reactions. My dear students, look at the first question. NEET 2020. Look at this. Tell me, the chats should run fast, guys. You should be answering these questions on your own. You should be answering these questions on your own. Tell me the answer of this question. Wait, guys. You just have to calculate basically the oxidation state of carbon here and the oxidation state of carbon here. If you look at this carbon, let its oxidation state is X. Hydrogen, the common oxidation state of hydrogen is +1. There are 4 hydrogen atoms. Net charge is 0. So X value is simply -4. Now what about this one? Let the oxidation state of this carbon is X. Chlorine, halogen shows -1 and 4 halogens. Net charge 0. So X value is +4. So the oxidation state of carbon is going from -4 to +4. -4 to +4, right? Done? Done? All right. NEET 2019. NEET 2019. What do you think about this one? Oxidation state of chromium in CrO6. Oxidation state of chromium in CrO6. Well, you should know the structure of CrO6 first of all. This is Cr. This is oxygen, oxygen, single bond. Now here, oxygen, oxygen, single bond. Again, here, oxygen, oxygen, single bond. This is your CrO6, right? Tell me. Tell me, guys. I gave you the structure. Now you should be doing it easily. Right? Look at this particular one. This particular bond between chromium and oxygen. Which one is more electronegative? Oxygen. So oxygen will attract the bonded pair towards itself, due to which oxygen gets -1, chromium gets +1. So again here -1, here +1. Again here -1, here +1. -1, +1. -1, +1. -1, +1. Okay? So look at the total charge on chromium. +1, +2, +3, +4, +5, +6. So chromium here is in +6 oxidation state. Simple. Right? Right? Who is this nonsense, this Vimal? Dude, you're very much uneducated, okay? Try to learn something. You're blocked. All right. This question has been asked in your AIMS examination, okay? What is the question? Which of the following molecules can act as oxidizing agent as well as a reducing agent? Quick. What about the rest questions of the last chapter? I told you I'll be taking 4 sessions to do the PYQs. This is the first session, right? In the second session, there'll be more questions of mole concept. Perfect. I'll be taking 4 sessions in total to cover all the PYQs. Quickly, guys. What do you think about this one? What do you think about this one? See, guys. See. First of all, this is sulfur here, right? Sulfur, oxygen, and fluorine. One thing which you have to understand. What is that? Have a look. If you look at H2O2, what is the oxidation state of hydrogen here? In hydrogen, sorry, what is the oxidation state of oxygen here? In peroxide, oxygen state of oxygen is -1, right? If you know about oxygen, what is the range of oxidation states which your p block elements show? The range of oxidation states in case of your p block elements is group number -18 to group number -10. This is the range of the oxidation states, right? Now, oxygen is basically group 16 element. So 16 minus 18 is -2, right? 16 minus 10 is +6. So this is the lowest oxidation state. This is the highest oxidation state. Now tell me, is oxygen here present in lowest or highest or the intermediate oxidation state? The oxidation state of oxygen is -1. It is neither lowest nor highest. It is in between. So if the oxidation state of oxygen here is in between, it is neither lowest nor highest. That means it can increase its oxidation state also. It can decrease its oxidation state also. If it can increase as well as decrease its oxidation state, that means it can behave both oxidizing agent as well as reducing agent, right? Perfect. Done. Perfect, people. All right. See how simple this question is. I mean, you should be killing this question. Tell me the answer of this one. Ionic equilibrium session will be done after a few days. Okay. Guys, this is something which is very easy. Potassium dichromate. Potassium dichromate. What is the formula for potassium dichromate? K2Cr2O7. You have to talk about the oxidation state of chromium here. How do you calculate oxidation state of chromium here? Potassium is the group first element. Will show +1 oxidation state. There are 2 potassium atoms. Let the oxidation state of chromium is X. So it becomes 2X. Oxygen will show -2 oxidation state. There are 7 oxygen atoms. Net charge is 0. When you calculate X, it will be simply +6. Right? It will be simply +6. Nothing more, nothing less. Yeah? All right. Tell me the answer of this question. At least this question you should be able to do on your own. This question you should be in a position to do on your own. Quickly, tell me the answer in the chats. The first compound is PO4 trinegative. We have to check the oxidation state of phosphorus. Let it be X. Oxygen is in -2 oxygen state. There are 4 oxygen atoms. Net charge is -3. So the value of X will be +5. The value of X will be +5. Right? Now, sulfur in SO4 dinegative. So this is your SO4 dinegative. Calculate the oxidation state of sulfur. This will be X. Oxygen will be in -2. There are 4 oxygen atoms. Net charge -2. So X value will be how much? +6. Right? So +5, +6, and it will be +6. So option D has to be the correct one. Option D has to be the correct one. Right? This sort of equation, again, you should be in a position to solve. Look at this one. Give it a try now. Give it a try now, people. Give it a try now. Every one of you. Every one of you. It is a similar sort of question which you should be able to solve. Guys, JEE level questions will be also solved. First, you solve the NEET level questions. These are your NEET level questions. First, you solve the NEET level questions, then we can go to the JEE level also. First of all, I should get the confidence, at least you are in a position to solve them. Only few students are answering, and some are telling, no, solve advanced questions. First, you solve the NEET questions. Once I get the confidence that you are giving me the answers, then yeah, we can go for JEE mains also, even advanced also. So basically, we have to talk about the increasing order of the oxidation state of sulfur in these, right? So first of all, if you talk about this sulfur, let its oxidation state be X. So it is going to be 2X because 2 sulfur atoms. Oxygen will show -2 oxygen state. There are 6 oxygen atoms. The net charge is -2. So it is 2X minus 12 is equal to -2. So what will be the value of X? X will be +2.5. X will be +2.5. So sulfur here is in +2.5 oxidation state. Number 1. S2O4 dinegative. S2O4 dinegative. Is it X or 2X? It's going to be 2X. Oxygen will show -2. 4 oxygen atoms. Net charge -2. So it's going to be 2X minus 8 is equal to -2. So it's going to be 2X is equal to +6. So X value will be +3. X is here in +3 oxidation state. Now, SO3 dinegative. SO3 negative. Let the oxidation state of sulfur is X, right? Oxygen will go with -2. 3 oxygen atoms. Net charge -2. So X value will be +4. So it is +4 here. Now we have to arrange them on the basis of their increasing oxidation state, right? So this is the increasing oxidation state only. Perfect or not? or not? Right? This is the increasing oxidation state only. What is it showing? This is 2x. This is minus 2 into 6 is equal to minus 2. So this is 2x minus 12 is equal to minus 2. So 2x will be equal to plus 10. Okay. Here's a calculation mistake. So this is plus 5 here. This is plus 5 here. Perfect. Similarly, you can check the others one. Let's check this one. Now S2O4 dinegative, we have already solved, plus 3. SO3 dinegative, sulfur, we have already solved, plus 4. S2O6 dinegative, this is plus 5. This is the increasing order of oxidation state. Okay. Perfect. Moving on to the next one. Tell me the answer of this question. Everyone. Tell me the answer of this one. Highest oxidation state of manganese. What is the highest oxidation state of manganese? Highest oxidation state of manganese is plus 7. Now check where is the oxidation state of manganese plus 7. If you look here, manganese will be in plus 7 oxidation state only. Right? When you check it out, plus 1, this is x, minus 2 into 4 is equal to 0. Here manganese will be in plus 6 oxidation state. Right? Here manganese will be in plus 4 oxidation state. Is that? Or plus 3. 3 to 6, 6 divided by 2, 3. So this will be plus 3. And here manganese will be in plus 4 oxidation state when you calculate it. Right? So this is not the question which will take a lot of time to solve. These are simple questions. Look at this one. Look at this one. Look at this one, guys. Everyone in the chats. Everyone in the chats. Everyone in the chats. Br2 to BrO3 negative. The oxidation number of bromine changes from. It is simple. Br2 is getting converted into what? BrO3 negative. Oxidation state of bromine here is 0. When you calculate here, it's plus 5. So 0 to plus 5. So it has to be option A. Right? It has to be option A. Absolutely. All of you are right. Chalo, moving on to the next one. NEET 2019. Which of the following is the example of disproportionation reaction? Disproportionation. If you look at the first example is Cu positive giving Cu di positive plus copper, right? Here the oxidation state is plus 1. Here it is plus 2. Here it is 0. 0 to plus 1 means increase. I mean, plus 1 to plus 2 means increase. Plus 1 to 0 means decrease. Do you understand? Plus 1 to plus 2, increase in the oxidation state, right? Plus 1 to 0, decrease in the oxidation state. So oxidation state of same element is increasing as well as decreasing simultaneously. And whenever you see such kind of the species wherein the oxidation state of the same element increases as well as decreases simultaneously, we say that species undergoes disproportionation. So this Cu positive undergoes disproportionation here because its oxidation state is simultaneously increasing as well as decreasing. Okay, look at the second option. MnO4 dinegative. MnO4 dinegative. Finally, it gives what? It gives MnO4 negative. And with MnO4 negative, what do we have? We have got MnO2 as well. Right? Oxidation state of manganese here is plus 6 when you calculate. Here it is plus 7. Here it is plus 4. If you look carefully, plus 6 to plus 7, increase in the oxidation state. Plus 6 to plus 4, decrease in the oxidation state. So oxidation state of same element is increasing as well as decreasing simultaneously. So this is undergoing disproportionation. So first one undergoes disproportionation, second one also undergoes. Here manganese is already in maximum, plus 7. Here the oxidation state of manganese is plus 7, which is maximum. So it cannot increase. So this cannot undergo. Here also manganese is in plus 7 oxidation state, already in maximum. So it cannot increase. So only 1 and 2 is the correct answer. Right? 1 and 2 is the correct answer. 1 and 2 are the correct answers. Okay. Tell me the answer of this one. Substances that are oxidized and reduced in the following reaction. Substances that are oxidized and reduced in the following reaction. What do you think? Quick, everyone. Everyone in the chats. If you look carefully, when you calculate the oxidation state of this nitrogen here, it will be what? 2x. Hydrogen shows +1. There are 4 hydrogen atoms, 0. So 2x minus 4 is equal to 0. So x value will be +2, right? +2 or -2. What we have done? N2H4, right? Tell me, quick. X value here is -2, right? So nitrogen here is in basically -2 oxidation state. This is hydrogen peroxide. Oxygen here is -1. Nitrogen 0. Oxygen -2. Now check it out. Check it out quickly. Check it out. So this is -2 to 0. Increase. Increase means oxidation. Increase means oxidation. So N2H4 is undergoing oxidation. N2H4 is undergoing oxidation. Simple. Right? -1 to -2. Decrease in the oxidation state. Decrease in the oxidation state means reduction. H2O2 is undergoing reduction. What we have to check? Substances which are oxidized and reduced. N2H4 is undergoing oxidation. This is undergoing reduction. So it's going to be N2H4 H2O2. It has to be option B. It has to be option B, right? How come it's option A? It's H2O here. But we are talking about H2O2. Moving on to the next one. Quickly. An example of the disproportionation. Example of the disproportionation reaction. What do you think? Sir, I am from PW. Can I join? Yes, you can join. Does not matter where you are studying. Okay. Now tell me the answer of this question. Which one is the example of disproportionation reaction? If I look at all these reactions, guys, when you talk about the last one, here copper is in +1 oxidation state, right? Here copper is in +2 oxidation state. Here copper is in 0 oxidation state. So +1 to +2, increase. +1 to 0, decrease. I would say oxidation state of same element is increasing as well as decreasing simultaneously. And if the oxidation state of same element increases as well as decreases simultaneously, we say this particular species undergoes disproportionation. So this is the example of disproportionation reaction. Right? Simple. Okay. You have to identify which one is the reducing agent in this reaction. First of all, you should know reducing agent itself undergoes oxidation. Reducing agent itself undergoes what? Reducing agent itself undergoes oxidation. So you have to check which one is undergoing oxidation. You have to check which one is undergoing oxidation. So if you look at this nickel, so first of all, this H positive, you have got nothing to do with this. Why is that? Because it just tells you whether the reaction is happening in acidic medium or basic medium. Whether there is H positive mentioned here, OH negative, nothing to do with this. It just tells you in which medium reaction is taking place. Leave this H positive aside. Now talk about the other ones. Here nickel is in 0 oxidation state. Here nickel is in +2. So 0 to +2, increase. Increase means oxidation. The one that undergoes oxidation, that's going to be your reducing agent, right? We have to check that only. So nickel is your reducing agent here. This was asked in your JEE mains examination long back. What do you think about this one? What do you think about this one? Quickly in the chats. Quickly in the chats, people. You have to calculate the oxidation state of phosphorus here, right? You have to calculate oxidation state of phosphorus. Again, you have to follow the same rule. See, barium is a group second element, so it will show +2. Hydrogen, its common oxidation state is +1. How many hydrogen atoms? 2 2s are 4. Plus phosphorus, its oxidation state is X, so it's going to be 2X, right? Oxygen, its oxidation state is -2, and there are 2 2s are 4 oxygen atoms. Net charge here is 0. Net charge here is 0. When you solve this, I think you get the value of X as +1 here. When you solve this, you get the value of X as +1 here. Okay, this question, it has been asked in multiple examinations. NEET 2018, AEEE 2013, JEE 2021. So give it a try. Give it a try, guys. Again, you should be in a position to solve this one too. Let me give you a simple method of solving this. First of all, leave this H positive and water aside. H positive is just giving me the idea about the reaction is taking place in acidic medium. You have got the reaction MnO4 negative plus C2O4 di negative. It gives Mn di positive plus carbon dioxide. This is the reaction. You have to balance it in acidic medium. Now, how do we balance this particular reaction? How do we balance the reaction? There are many ways. I'll tell you the simplest one. Tell me the oxidation state of manganese here. It will be plus 7. Oxidation state of carbon here. It will be plus 3. Manganese plus 2. Carbon plus 4. Right? So, plus 7 to plus 2. Plus 7 to plus 2. What is the change in the oxidation state? Plus 7 to plus 2. Change. Final minus initial. The value is 5. Right? So, I would say its n factor is 5 basically. Plus 3 to plus 4. The change is 1. 1 is the change for 1 atom. I have 2. So, its n factor is 2. Now, just crisscross these n factors. Crisscross these n factors, guys. Crisscross these n factors. That means, once you get the n factor of reactants, you need to crisscross them. Make this 2 as the stoichiometric coefficient here. Make this 5 as the stoichiometric coefficient here. After crisscrossing them, balance all the atoms except hydrogen, oxygen. 2 manganese, 2 manganese. 5 2s are 10 carbon, 10 carbon. Right? Now balance oxygen. Now balance oxygen with the help of water. So 4 2s are 8, 5 4s are 20. So 28 oxygen atoms on this side. 10 2s are 20. 20 oxygen atoms on the other side. Which side is oxygen deficient? Right side. How many oxygen deficiencies? 8. So add 8 water molecules on this side. Right? On that side, which is basically oxygen deficient. So oxygen is balanced. Now balance hydrogen. 8 2s are 16 hydrogens. So add 16 H positives on this side. The reaction is balanced now. The reaction is balanced. So what do we have to do? First, get the n factors of reactants. Then crisscross these n factors. Then balance all the atoms except hydrogen, oxygen. Then balance oxygen with the help of water. Then balance hydrogen with the help of H positives. That is a general way of solving these sort of questions. Okay? Got it? Done? Moving on. Moving on, guys. What do you think about this one? This question you can only solve if you would have, studied n factor calculation as well as redox titration. It's a simple question only. The question is, you are making KMnO4 to react with what? To react with H2O2 in acidic medium basically. What is the n factor of KMnO4 in acidic medium? 5, right? Moles of KMnO4 are given as 1. N factor of H2O2 will be 2, right? And its moles are to be calculated. Its moles are to be calculated. You just use the equivalent concept. You can say N1, moles of KMnO4 into its N factor has to be equal to moles of H2O2 into its N factor, right? N1 value is 1, N factor 1 is 5, N2 value to be calculated, and this is 2. So N2 value here comes out to be 5 by 2. That was to be calculated. Simple. Right? Again, this sort of a question you can only solve if you know the concepts behind it. If you know the concepts behind it. Let's go to atomic structure. NEET 2020. Tell me the answer of this question at least. This at least everyone should be solving. Quick. Quickly, guys, everyone. Number of protons, neutrons, and electrons in Lu, atomic number 71, mass number 175. Atomic number gives you electrons, so electrons are 71. Atomic number also gives you protons, so protons are also 71. Now neutrons will be mass number minus atomic number. So 175 minus 71, that will give you the number of neutrons. Done? You can select. We have to check the protons. Protons are 71, right? Then neutrons. And then electrons. Electrons are also 71. So it has to be option C. Right? NEET 2021. A particular station of All India Radio New Delhi broadcasts on a frequency of 1368 kilohertz the wavelength of the electromagnetic radiation emitted by the transmitter. Frequency is equal to C divided by lambda, right? We have to calculate lambda. So lambda has to be equal to C divided by nu. So just a matter of calculation, right? C is velocity of light, 3 into 10 raised power 8. And this was in kilohertz, so into 10 raised power 3, so it comes in hertz. So just a matter of calculation and you are done. But this will take some time for the calculation, right? This sort of equation will take some time to do the calculation and stuff. Otherwise, there is nothing here. There is no great concept here. Tell me, what do you think about this one? AIMS 2016. AIMS 2016, guys. What is the relation between energy and N, radius and N? First of all, radius formula. Radius of the nth orbit is equal to R naught N square divided by Z. Right? Total energy formula. Energy of the electron in the nth Bohr's orbit is equal to what? Minus 13.6 Z square divided by N square. These are the formulas. Now you can relate. Energy and N square, they are inversely. So this one is correct. This one is also correct. Perfect. Radius and N square, they are directly proportional. So we have to go with option B. Right? We have to go with option B. NEET 2022. Check it out. Quick, guys. Everyone in the chats. Are you done with this? Guys, this question is based on the simple formula. I told you a few minutes back, radius of electron in the nth Bohr's orbit is called R naught N square divided by Z. What does that mean? That means R1 divided by R2 has to be equal to N1 square divided by N2 square multiplied by Z2 divided by Z1, right? Now, radius of the second Bohr's orbit of He positive. So on one side we are given with He positive, on another side we are given with Li di positive, right? So first of all, what is their atomic number? Tell me their atomic numbers. Hydrogen, helium, lithium, atomic number 2, atomic number 3. If the radius of the second Bohr's orbit, so N1 value is 2. And here we are given with third Bohr's orbit. So N2 value is 3. So put the values and we are done. And the radius of second Bohr's orbit, so R1 is also given, 105.8. We have to calculate R2. So all the values are here. Put it in this equation and get the value of R2. Right? Get the value of R2. Okay? And when you do the calculation and all, its answer will come out be option A. Right? I give you the formula, you can use that. Okay, one theoretical question, NEET 2019. NEET 2019. What do you think? Quick. This question everyone will know because it's a theoretical question, right? So if you don't remember, see, how do we check it? You have got Lyman series, you have got Balmer, you have got Paschen, you have got Brackett, you have got Fund, right? These are the series, right? Here you'll write U, V, I. U stands for ultraviolet, right? This is visible. This is infrared. This is also infra. This is also infra. Sometimes they might mention it as far infra. Here also they might mention as far infra. So remember this particular thing, right? And you'll be done. And you will be done. Okay? Done, people? Done with this? Okay. Moving on to the next one. NEET 2019. NEET 2019. Solve it quick. People are coming up with 4F, is that? See, first of all, how do you calculate total number of nodes? Total number of nodes is nothing but it is equal to n minus 1, right? How do you calculate angular nodes? Angular nodes is equal to the value of L. How do you calculate spherical or radial nodes? How do you calculate spherical or radial nodes? It is n minus L minus 1, right? Now, orbital having 3 angular nodes and 3 total nodes. So total nodes are 3. That means n minus 1 is 3, which means that n is equal to 3 plus 1, 4, right? And there is only one option wherein n is mentioned as 4, and we are done, right? NEET 2019, quick. NEET 2019, quick. Everybody. You have to arrange these orbitals on the basis of their energy. So which rule you have to use? You have to use n plus L rule, right? N plus L rule says what? More the value of n plus L, more the energy. More the value of n plus L, more the energy. Now, if n plus L is same for 2 orbitals, then go with the value of n. More n means more energy. More n means more energy, right? Now tell me the answer, guys. This is something which you should know exactly. You should know this. This is something which you should know. You just have to get the value of n and L for everywhere. I mean everywhere. And you'll be done. People are coming up with the option A. Option A is the correct one. See, here you are mentioned n value is 5. L value, azimuthal contour for F is 3. So 5 plus 3 is 8. 6P. N is 6. For P, L value is 1. 6 plus 1, 7. Similarly goes the other ones too. And these are the two wherein n plus L value is same. So you'll be deciding on the basis of n. More the n, more the energy. So this one will have more energy than that of this one. 5P will be having more energy than that of 4T. Right? Okay. Tell me, which of the following has maximum energy? Which of the following has maximum energy? Quick. This I'll give you as the homework question. I want to know its correct answer in the comment section. Okay? I know there will be a lot of students who will get stuck in this question. But I want you to get stuck first. Then I'll tell you what's its answer. I think a lot of students have already given the answer. A lot of students have already given the answer. I'm keeping this as a homework question still. I'm not going to give you the answer of this. This is the homework question. Tell me the answer of this one. Which of the following arrangement is possible? 2 times the same question has been repeated in the AIMS examination. Which of the following is possible, they are saying. Which of the following is possible, they are saying. Aisha, it was option C in the last case. Okay. All right. It was option C. The question is, which of the following arrangements is possible? See, this is N. This is L. L is from 0 to N minus 1, right? M is from basically minus L to plus L. And S can have only 2 values. Plus 1 by 2, minus 1 by 2. You have to take care of these things. That's it. You're done. So see, N value is 5. Right? So L can have values from 0 to 5 minus 1. 0 to 4. It can have value as 0. It can have value as 1, 2, 3, 4. M has the value of minus L to plus L. Minus L to plus L. Right? Now, L here is 2. So it is minus 2 to plus 2. Minus 2 to plus 2, anything. So correct. S can be plus 1 by 2. So first one is correct. Direct. You don't have to check the rest of the things. First one is directly correct. Okay? First one is directly correct. Let's go with chemical bonding. Let's go with chemical bonding. Okay? Tell me the answer of this. See, here you need not pen and paper. You don't need pen and paper here. You should be able to solve these questions quickly. Quickly, everyone. Everyone means everyone. Sir, enjoying the session. Even I'm enjoying the session. Because this is something which you have to solve. I don't have to solve anything. The question is, which of the following is electron deficient? Guys, BCl3 is electron deficient. What are you talking about? BCl3, right? It has got only, boron has got only 6 electrons in its outermost shell. 3 bonds. 6 electrons. So this is the electron deficient species. Increasing order of covalent character. Increasing order of covalent character. Tell me. Increasing order of covalent character. How do you check this? You just have to use the Fajan's rules. Nothing more, nothing less. Fajan's rules, right? So this is Na positive, Cl negative. Rb positive, Cl negative. Mg di positive, Cl negative. Al tri positive, Cl negative. Right? More the charge on cation, more the polarizing power of cation, more the covalent character. So 4 will have maximum covalent character. We have to talk about the increasing order. So 4 will have maximum covalent character. 4 will have maximum covalent character. Followed by third. Followed by third. Right? Then Na positive, Rb positive. Which one has got lesser size? Na positive has got lesser size. Lesser size means more polarizing power. More polarizing power means more covalent character. So this is the increasing order. Option 3. I was supposed to check the increasing order. Right? I was supposed to check the increasing order. Few days back, I had posted one short also. Short of 2 minutes. Wherein I've explained Fajan's rules in detail. You can check that short. You can check that short. 2-minute video it was. 2-minute short it was. You can solve that. You can solve this sort of a question by just checking, by just seeing that short. Right? That's why every content on this channel is important, guys. Okay? So don't miss out anything. Don't miss out anything. Trust me on that. Don't miss out anything. Tell me the answer of this. PCL5, SF6, BRF5, BRF3. Quick, 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 quick. Quick. Quickly, everyone. Everyone in the chats. Check it out. First of all, PCL5. It's a very common compound, PCL5. Right? PCL5, sp3d, ab5l0, trigonal bipyramidal. Everyone knows this. Right? Everyone knows this. Trigonal bipyramidal. So A you have to match with 4 directly. A you have to match with 4. Right? Here B is being matched with 3. So I'm not going to check B. I'm not going to check B. C is being matched with 1. C is being matched with 1. C here is matched with 2. So BRF5. BRF5. What is the type of BRF5? It is going to be AB5L1. AB5L1 type. I hope you know. BRF5 is going to be AB5L1. It's going to be square pyramidal. So C with 1. C with 1. So it has to be option A only. Okay? You just should know one thing. What is the type of the molecule? Once you know the type of the molecule, you can easily talk about the shape of the molecule. Again, I have posted one short video wherein I have talked about how to check the shapes. Okay? Chalo, next one. Which of the following pair of compound is isoelectronic and isostructural? Isostructural. When you have to check whether two compounds are isostructural or not, what do you have to do? You just have to check the type of the molecule. If the type of the molecule is the same, if both the molecules have got same type, they are going to be isostructural. If both the molecules have got same type, they are going to be isostructural. I'll show you how to check the type of the molecule, okay? I'll show you. For example, if you look at the second option, IBr2 negative. IBr2 negative, right? Iodine, how many valence electrons it has? Iodine has got 7 valence electrons. There's a negative charge, so 7 plus 1 makes it 8. How many surrounding atoms are there? 2. Surrounding atoms means sigma bonds. So 2 sigma bonds. Out of 8 valence electrons, 2 valence electrons have been used to form 2 sigma bonds by iodine. Iodine has got 8 valence electrons. Out of 8, it has used 2. So 6 are left as such. 6 are left as such in the form of 3 lone pairs. Right? So sigma 2 lone pairs 3. So the type is going to be AB2L3. And AB2L3, what is going to be? Okay, we do not talk about the shape, nothing, right? We just have to check the type of the molecule. Now, similarly, XCF2. XCF2. Check the type of the molecule. Xenon, how many valence electrons? 8. How many surrounding atoms? 2. So sigma bonds 2. How many lone pairs? Out of 8 valence electrons which xenon has, it is using 2 valence electrons to form 2 sigma bonds. So there will be 6 valence electrons left as such in the form of 3 lone pairs. So again, the type of the molecule is nothing but AB2L3. So is the type same? Yes, the type is same. If the type is same, they are going to be isostructural. They are going to be isostructural. Right? What about this one? This was your JEE mains question. Are you guys done? Are you guys done? We are given with NO3 negative, NO2 positive, NH4 positive. First of all, okay, let me check one by one. We have got NO3 negative, right? Nitrogen. How many valence electrons? 5, right? There is a negative charge. So 5 plus 1 makes it 6. How many surrounding atoms? 3. 3 surrounding atoms means 3 sigma bonds. How many lone pairs? How many lone pairs? 0 lone pair on nitrogen. Steric number is sigma plus lone pair. Hybridization will be sp2. Number 1. You have got NO2 positive. Nitrogen. How many valence electrons? 5. There's a positive charge, minus 1, makes it 4. Surrounding atoms, 2. So sigma bonds 2. Lone pairs. 0 lone pair on nitrogen. Steric number. Sigma plus lone pair, 2. Hybridization, sp. NH4 positive, you should be knowing directly is sp3. Right? Now, which one is the correct one? sp2, sp, sp3. sp2, sp, sp2, sp, sp3. So it has to be option 3. It has to be option 3. Tell me the answer of this one. This is something at least you should be in a position to do. We are given with I3 negative, right? I3 negative. Can I do one thing? Can I write I3 negative as I2 negative? Right? Talk about this iodine. How many valence electrons it has? 7. There's a negative charge. So 7 plus 1 makes it 8. How many surrounding atoms? 2. So sigma bonds 2. How many lone pairs on central iodine? How many lone pairs on this iodine? Out of 8 valence electrons, it has used 2 to form 2 sigma bonds. So 6 will be left as such in the form of 3 lone pairs. So this central iodine, it has got 3 lone pairs. Was I supposed to check the number of lone pairs of electrons on the central iodine? Yes, it is 3. So option 1 is going to be the correct one. Yeah? Okay. Give me the order of the dipole moment. Give me the order of the dipole moment, people. Everyone. Give me the order of the dipole moment. First of all, CH3, is it donating or withdrawing? It is donating group, electron donating. It donates electrons. It donates electron. It donates, right? When it donates, it gets delta positive, delta negative. And moment direction is from positive to negative. Positive to negative. They cancel out. So net is 0 here. Net dipole moment is 0, right? Positive to negative. Positive to negative. So one moment is pointing downwards. One moment is in this direction. And their angle is right now 120 degree, right? Positive to negative. Positive to negative. One pointing downwards, one pointing in this direction. Theta here is 60. Lesser the angle between the two vectors, more will be the resultant. Lesser the angle between the two vectors, more will be the resultant, right? Lesser the angle between the two vectors, more will be the resultant. So resultant dipole moment is maximum in the last case. So 3 will be maximum, followed by 2, followed by 1. Yes, so option 2. Option 2, that's it. Right? What do you have to do? CH3 is electron donating group. If it donates electrons, so this will be delta positive, delta negative. Positive to negative is the direction of movement. Positive to negative, positive to negative, positive to negative. Then you have to do the vector calculation and you are done. Lesser the angle between two vectors, more will be its resultant. Simple. Okay, let me check what will be your answer here. CH3 is electron donating group. NO2 is withdrawing. If it donates electrons, so this will be delta positive, delta negative, positive to negative. This is electron withdrawing. If it withdraws electrons, when it withdraws electron, it gets delta negative. This gets delta positive. So positive to negative. One pointing downwards, one pointing in this direction. Angle is 120, right? Positive to negative. Positive to negative. One pointing downwards, one pointing in this direction. Angle is 60. Positive to negative. Positive to negative, right? Angle between two vectors here is 0. So lesser the angle between two vectors, more is going to be its resultant, right? So 3 will be having maximum dipole moment. 3 will be having maximum net dipole moment, followed by 2, followed by 1. So 3 to 1 is the answer again. So it has to be option 2. It has to be option 2 again. This is also your asked question in NEET. Tell me its answer quick. Tell me its answer quick in the chats. Quickly, guys, this is something which you should know already. Done? Option C, you are saying. So first of all, this is boron trifluoride, BF3. It's a famous molecule, BF3. Its net dipole moment is 0. Beryllium difluoride, BeF2, linear, net dipole moment 0. Carbon dioxide, linear, net dipole moment 0. 1,4-dichlorobenzene, again net dipole moment. I mean, these are all the known molecules, right? Which you all should be knowing already. These are all the known molecules, right? So if you do not know, let me tell you, whenever you see a molecule of the type AB2L0, or you see molecule of the type AB3L0, or you see molecule of the type AB4L0, or you see molecule of the type AB5L0, AB6L0, yeah, AB2L3, or AB4L2, AB4L2, yes. All these molecules, their net dipole moment is 0. They will always have the net dipole moment of 0. Okay? They'll always have the net dipole moment of 0. Got it? Tell me the answer of this one. Tell me the answer of this one. Quickly. Okay, let me show you the options as well. I think I'm hiding the options. Which of the following is polar? First of all, you should know one thing. Any molecule whose net dipole moment is 0, that's going to be non-polar molecule. We call that as non-polar. And any molecule whose net dipole moment is non-zero, that molecule is a polar molecule. Remember that. Okay. Now, when you check the types of these molecules, this is SF4. SF4 means AB4L1 type. SIF4, it will be AB4L0 type. XCF4, this will be AB4L2 type, right? BF3, this will be AB3L0 type, right? AB4L0, AB4L2, AB3L0. I gave you all these molecules few minutes back. I told you this is the category of molecules wherein the net dipole moment is 0. So they are going to be non-polar. So polar one is only SF4. Polar one is only SF4. Right? Polar one is only SF4. All right. Tell me the answer of this one. Arrange the following on the basis of their bond order. I've already made a shot on bond order trick. You should know that. If you do not know, let me tell you. Whenever you see a 14 electron species, its bond order is going to be 3. 15 electron species, bond order 2.5. 16 electron species, bond order 2, 17 electron species, bond order 1.5, 18 electron species, bond order 1. Similarly, 13 electron species, bond order 2.5, 12 electron species, bond order 2, 11 electron species, bond order 1.5, and 10 electron species, bond order 1. Right? You can use this trick generally, right? There is one exception, that is, I think, CO positive. CO positive means 8 plus 6, 14, 13 electron species. 13 electron species, that should have bond order of 2.5. It's not 2.5, it's 3.5. CO positive. CO positive is the only exception. Okay, do remember it as an exception. CO positive is basically a 13 electron species. Its bond order should be what? 2.5. Its bond order should be 2.5, but it's not 2.5, it's 3.5. So tell me, first of all, O2. O2 will be having 8, 16 electrons. O2 negative will be 17 electron species. O2 di-negative, 18 electron species. O2 positive, 15 electron species. Now, on the basis of number of electrons and bond order, you can arrange them. You can arrange them. Right? You can arrange them. Tell me, which one among these will have highest bond order? NO, nitrogen, atomic number 7, oxygen, atomic number 8. 8 plus 7, it's a 15 electron species. 6, 7, 6, 7, 13 plus 1, 14. It's a 14 electron species because there is a negative charge. 6, 7, 7, 6, 13. 13 minus 1, 12. 12 electron species. 7 and 6. 7 6s, 13. 13 electron species. Right? 14 electron species has got bond order 3. Remaining all will have less than 3. Right? So which of the following has got maximum, highest bond order? It's CN negative. It is CN negative. It is CN negative. Correct? Perfect. So with this, your chemical bonding is also over. So my dear students, in the today's session, we are done with 4 chapters. One is mole concept, one is redox, one is atomic structure, and one is your chemical bonding. I think this much is enough for today. I told you I'll be conducting total 4 sessions. I'll be conducting total 4 sessions for PYQs. And in 4 sessions, all your NEET PYQs in chemistry, all your NEET chemistry PYQs will be done in just 4 sessions. Right? Out of which today was the first session. Out of which today was the first session. Okay? I think this much is enough. Next session, I'll let you know when it's going to happen. I'll keep you updated on my Telegram. I hope you are the part of the Telegram channel already. The name of the Telegram channel is Wassim But Chemistry Official. Wassim But Chemistry Official. This is the name of the Telegram channel. Okay, you can join in. I'll keep you updated. I'll post a short also, wherein I'll let you know when is the next session. Right? By the way, all PYQs does not mean the 40-year PYQs. All PYQs means 5 to 7, 10 years PYQs almost. So when you talk about the 10-year PYQs, 10-year PYQs means 45 into 10, 450 questions in total. Okay? If I solve 10-year PYQs with you, that means 450 questions only. Okay? Perfect. Chalo then. I'll take a leave with this. I'll see you guys soon. I'll keep you updated with the next session when that is going to be. Until then, you guys take care. Do let me know in the comment section whether you actually liked this sort of a session, so that I'll keep on coming with such kind of more sessions in all the subjects as well. Right? And as I told you, I'll be doing a marathon of those 50 topics, which I told you already. Okay? Do let me know in the comment section if you want that or not.